Hello, this is question number 11, homework number 16. Consider the definite integral from 0 to 1 of x to the 6th power over x to the 7th plus 9 all to the 7th power dx. This question wants you to find the integration using the substitution method. It breaks down the steps for you in order to figure that out. Now, there is a difference between the way I showed you and this way. The main difference is they keep everything in terms of u, and because of that they have to change the lower limit and the upper limit of the integration into new limits. I'll show you how to do it this way. So we have the integration from 0 to 1 of x to the 6th power over x to the 7th power plus 9 to the 7th power dx. First of all, I'm going to rewrite this so you can see exactly how I do the substitution. So I will rewrite it as the integration from 0 to 1 of 1 over x to the 7th power plus 9 to the 7th power times x to the 6th power dx. I see I have a denominator, and that denominator is an expression raised to the 7th power. So I will choose u to be what's inside of these parentheses, which is x to the 7th power plus 9. So that is the option for u. I'm going to type it here, x to the 7th plus 9. The question is asking to find the derivative of u, which is du. So du in this case is equal to 7x to the 6th power dx. Notice how in this case I have 7x to the 6th power dx, but in the original integral I have x to the 6th dx. So I need to remove this 7. I'm going to divide both sides by 7. So now I will have du over 7 is equal to x to the 6th dx, which is this amount. I am going to substitute everything into the original integral and turn it into an integral in terms of u. So I will change that integrand and differential into the new integrand and the new differential. So I will have the integral from a to b. It's no longer from 0 to 1 because the integrand is going to change into a function in terms of u, and the differential is going to be in terms of u as well. So this will be 1 over u raised to the 7th power. I just substituted u with its value times the new integrand, which is x to the 6th dx. It will turn into du over 7. So du over 7. So I can rewrite this as the integral from a to b of 1 over 7 times 1 over u to the 7th power du. So what should go here is 1 over 7 times 1 over u to the 7th power, like so. So this is how I wanted it to look like. Eventually, I have to switch the lower limit and the upper limit of the integral from the old ones in terms of x into the new ones in terms of u. So this is basically when x is equal to 0, and this is when x is equal to 1. I know what u is because I assumed that u is equal to x to the 7th power plus 9. So I'm going to write it here. U is basically x to the 7th power plus 9. So when x is equal to 0, that means the new limit, which is a, u is equal to a. So a will be, you plug x in it, 0 to the 7th power plus 9, and that will give me a is equal to 9. When x is equal to 1, this will lead to b is equal to what u is when we plug 1 in here. So it's going to be 1 to the 7th power plus 9, which is going to be b is equal to 10. So a is 9 and b is 10. A is 9 and b is 10. Based on what I know about u is x to the 7th plus 9. So if I plug x is equal to 0, it's going to give me the first value of u, which is a. if I plug x is equal to 1, it's going to give me the upper limit of that integral in terms of u, which is when we plug x is equal to 1 into u, which is equal to 10 in this case. I forgot to plug this in. du is 7x to the 6th power. So I hope this video helped you understand how to answer this type of question.